All right, Algebra AB, we are going to do 4 more factoring problems here. Again, this is Mr. Johnson. So I would just pause this real quick and make sure you copy all 4 of these problems down, numbers 8, 9, 10, and 11 in today's lesson. These are not much different than the problems that we've done so far, but there's a couple patterns that I want to point out in 10 and 11, and then also just some complications with the signs in numbers 8 and 9. So if we look at factoring number 8, and again, I'm going to try and go away from the area model. So I know that x times x is what gives me x squared, and I need to choose 2 numbers that multiply to be 40. Now there are tons of numbers that multiply to be 40, right? That's just a few of them there. Actually, I think I might have gotten all the factors. So if I try and think, well, which one of these would work? Well, none of these numbers add to a negative 13, right? They're all adding to positive values. Well, I have to think, if I want to multiply to a positive 40, it's possible that both numbers are negative, because a negative times a negative is a positive. And a negative plus a negative will also give me a negative 13 in the middle there. So I look at making all of these negatives, and now I see which combination of these numbers adds to negative 13. And I see that's negative 5 and negative 8. So if I go x minus 5 and x minus 8, this is the correct factored form. Now again, you can always double check by redistributing. I get x squared minus 8x minus 5x plus 40 with that negative 5 times that negative 8. Negative 8x and negative 5x, that's what gives you your negative 13x in the middle. So my final answer here is x minus 5 times x minus 8. And again, the order doesn't matter. If you wrote x minus 8 first, no problem. Number 9, again, tricky sign. I notice we're multiplying to a negative, so that's got to be a positive times a negative. And we're adding also to a negative 5x in the middle. So I know that the negative number needs to be the larger of the 2 numbers if we're going to add to a negative. So I think of factors of 36. We've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. That's a lot of them. Now, what combination of those can add to negative 5? I also like to think of it as having a difference between the 2 numbers of 5, meaning I can get to 5 or negative 5 by adding, subtracting, combining these numbers. So 1 and 36 is out, 2 and 18, 3 and 12 are 9 apart, 6 and 6 are the exact same number, but what about a combination of 4 and 9? They add to 13, but if one is positive and one is negative, we can make 5 or negative 5. So as I factor this, I know we have x and x. They have to multiply to 36. There's my 4 times 9. And if I want to add to a negative 5, I'm going to go with a negative 9 and a positive 4. That gives me negative 9x plus 4x is negative 5x. You just be very careful to look at those signs. All right. Next problem here is number 10. And in number 10, we need to factor x squared plus 10x plus 25. All positives here, so I'm in pretty good shape knowing that I'm only going to be multiplying positive numbers together. X and x multiplies to 25, or 25 and 1, or 5 and 5. Now we have to add to 10x, so it looks like 5 and 5 right away. They add to 10, they multiply to 25. That is factored. Now a couple things with this. We can also write this as x plus 5 quantity squared, because that means to repeat x plus 5 times x plus 5. So that would be a fine answer as well. This is known as a perfect square trinomial. And that's because 5 times 5 is 25. We have that perfect square of 25 right here, and 10 is 5 doubled in the middle. So perfect square trinomials, we can always think of square root of 25 as 5. 10 divided by 2 is 5. So we can certainly see that pattern there, and that's always going to factor to x plus 5, right? That same factor multiplied by itself. Let's see if that happens in number 11. I see 49 is a perfect square. I know that that's 7 times 7, but we have to add to a negative 14. I wonder if that could be negative 7 and negative 7, multiply to positive 14 or 49, and add to negative 14. So if we write this as x minus 7 times x minus 7, that gives us our negative 14x in the middle, and negative 7 times negative 7 gives us our positive 49. Again, that could be written as x minus 7 squared. That's another perfect square trinomial. All right, you guys are ready to try a couple practice problems on your own.